welcome back to Algebra 1. Our goal for today is to continue working with our simplifying expressions using power rules. At this point, we should know rules 1, 2, 3, 4, and 5. So today we're going to add in rule number 6. So a little bit of review here on our power rules so far. So rule number 1, a product of a power rule, says that if I have all multiplication, and anywhere in that multiplication problem, if my bases match, my big number part of my powers match, then I can take anything with that same base and simplify by adding up their little number called the exponent to get a more simplified, reduced version. Rule number 2, a power of a power rule says that if I have a power, a base with an exponent, and that base with an exponent has another exponent, then the exponents can get shared to each other, and when we share them to each other, it is a multiply, not an add, so be careful. Rule number 3, a power of a product power says I have a multiplication problem that has a power. If I have a multiplication problem that has a power, then the power can get shared to each part of the multiplication problem. Now be careful, when I take this power and I share it to these items on the inside, I often have to do, I'm using 3 to share it, and when I share it, I have to use rule 2 to multiply because some of the things on the inside might already have a power. So be careful there. All right, rule number 4, if I have a power or an exponent of 0, anything that has an exponent or power of 0 is really something that has a value of 1. The whole thing that has the exponent of 0 gets removed, and in its place gets replaced a 1 in the problem because those things are equivalent. Something to the 0 says don't write that item, and all you have left is the 1 times that was originally there. And then rule number 5, which in my opinion is the trickiest of them all, when I have a negative exponent, I have to simplify and make it a positive exponent. I will never leave a final simplified version with a negative exponent still involved, and so I need to use what I'm calling the stay or go rule. If it's negative and it's on the top, now keep in mind, just the little number, the exponent negative, not the big number. If the big number, the base is negative, don't move it. That's fine. We can have negative bases. We just shouldn't have negative exponents when we're done simplifying. So if my negative exponent's on the top, it needs to go to the bottom, and when we do that, the point of moving it is to make the power or the exponent positive. If it's in the bottom with the negative exponent, it is going to go to the top and become a positive exponent. It's equivalent to what was originally there, just in its more simplified positive exponent version. So for today, rule number 6, what's called a quotient of power property. Now, this word quotient is our fancy word for I have division, right? Or what's the answer to a division problem? So in algebra, typically division is shown to us in the format of a fraction. So if I have a fraction which is showing division, how do I simplify when I have powers? All right, so I'm going to backtrack for a second. If we have all multiplication, right? All multiplication, and we have matching bases like this, our A's all match, then we can simplify using rule number 1 by adding them up, right? So this would be an A to the 4 plus 3 plus 2 plus 5. And when we add those all up, it will give us our simplified power, right? So 4 plus 3 plus 2 is an A to the 14th. And it would give us our more simplified, more basic version, right? So the rule is when I multiply the same bases, I add the little number. So our rule for today is, what if I'm dividing with the same base? Instead of adding, I subtract to get the final result. All right, so quotient of powers property, when dividing powers that have the same base, we subtract the exponents to get the simplified version. So this is an example, all right? This is just an explanation. All right, if we have one big quotient, which is going to look like a fraction here, A to the 5th on the top, A to the 3rd on the bottom, right? Now, I know it's a quotient because it's in fraction version. Since these bases match, then we could subtract their exponent to get the simplified version. But the way that we subtract is important. It's always the top minus the bottom, in that order, because if I do bottom minus top, I'm going to get a different result, so be careful. It's this one first, this one second with subtraction now in between, not add. So be careful. All right, now this problem, right? Again, that example. I have the same base on the top and the bottom of a quotient. Right? Since these a's match, I can simplify by subtracting the exponent. The top one goes first. The bottom one goes second. And you can see why the order matters here, because for this one, we had 5 minus 3, which gave us an a squared. For this one, we have 3 minus 5, which would give us an a to the negative 2. And then I'd have to say, wait, I'm not done. I have a negative exponent, and I can still keep going and doing more simplify by taking it from the top, moving it to the bottom, and making it a positive 2. In this case, my 1 over a squared would be the final simplified, most simplified version. So be careful. The order of how you subtract the exponents is important. It's top minus the bottom in that order. All right, so let's look at a couple examples. Number one, we have a 3 to the 7th over a 3 to the 5th. Again, if I just type this in my calculator, 3 caret button 7, a divide, a 3 caret button 5, is going to give me the approximate decimal value of what all that's going to be. We don't want that. We want the final simplified version. So make sure you're using your rules and not just typing these into our calculator. All right, so 3 to the 7th, we have 3 on the top as our base, 3 on the bottom as our base. And it's a quotient. So the way to simplify would be to combine them together and subtract the top exponent minus the bottom, right? So we're going to say we have one big thing of 3. It's now all in the top part of our fraction when we do our subtraction, right? So we've taken it all to the top, and we're doing top minus bottom. Right? It's not in the denominator, it's in the numerator when we subtract our exponents. All right, 7 minus 5 would just give us a 3 squared. And then 3 squared we can now evaluate because we have a base with a positive exponent, which would give us just a value of 9. All right, example number 2. We have an m to the 12th over an m to the 3rd. Since we have matching bases on both the top and the bottom, right? We both m here, m here. That means we can bring it all to the top and subtract that little number called the exponent to get a simplified version. All right, so we move this all up to the top, and we say this becomes an m to the 12 minus 3. All right, m to the 12 minus 3 would just give us a value of now m to the 9th. All right, nothing else left to simplify, so we know that's our good final version. All right, example number 3. C to the 4th times c squared all over c to the 7th. Now, there's a couple of things going on here. Everywhere is a base of c, right? C, C, C. Everything can kind of sort of go together because the bases match. However, I'm going to start with rule number 1. Because if I have something right on the top, I can simplify a little bit. So I want to deal with that fact that that top by itself can get simplified or condensed before I deal with the fact that there's stuff on the top and the bottom. That will make my life a whole lot easier. All right, so I have c to the 4th times c to the 2nd. Since this is times, we can take those two things and add them up, right? So we have a step to show here. C to the 4 plus 2 all over now c to the 7th, which isn't changing. All right, simplify the top. We have a c to the 6 over a c to the 7th. Now that we have it as simplified as possible, we'd say, all right, we have matching things on the top and the bottom. So I want to bring it all up to the top and do the subtraction of the powers. So c to the 6 minus 7. All right, it's all back up now in the numerator for right now. All right, we have c to the 6 minus 7, which would give us c to the negative 1. And right now we say, like, all right, I'm done. There's nothing else I can condense. However, we have a negative exponent, so we have to keep going. We're not done simplifying until all our powers or all our exponents are positive numbers. So right now it's in the top. So it needs to go to the bottom and become a positive. So 1 over what is now c, or c to the positive 1. So I can leave it like that, 1 over c. That is the most basic, most simplified, best way to write it. But I could also put it as 1 over c to the 1st, right? That would work also. All right, example number 4. We have a 5 times b squared over b. Please remember that a b by itself really has a power. The unwritten power there is a 1. It might be helpful to write that in. Now, on the top for this one, we don't have something we can simplify. On the bottom, we don't have something to simplify. So now we're going to go straight to, I have matching bases on the top and the bottom. When that's the case, I have a fraction where my bases match. I'm going to bring it up and do subtract to simplify. So I have 5 times b to the 2 minus 1. All right, we'll simplify our power. If we end up with a negative exponent, we'll keep going. If it's positive, in this case, we would be done simplifying. So 2 minus 1 would just give us a 1, which is positive. So we don't need to do stay or go here. All right, we're going to end up with 5b. 5 to the positive 1 stays put. B to the positive 1 would stay put. We're done simplifying. No need to do any go in the stay or go rule there. All right, number 5, 1 over y to the 5th times y to the 3rd. All right, at first glance, it sort of looks like there's nothing to do here, right? I don't have a quotient here, right? I have nothing that matches here. Nothing that matches on the top, nothing that seems to match on the bottom. But you need to remember your rules for multiplying fractions from elementary school. When you multiply with fractions, you multiply everything on the top to get one big new top. And you would multiply everything on the bottom to get a new bottom. So this y to the 3rd is really y to the 3rd over 1, right? That's the denominator when there isn't one. The unwritten number is a positive 1. So from here, I can take everything on the top and multiply it. So 1 times y to the 3rd would just give us a y to the 3rd. Y to the 5th times 1 would just give us a y to the 5th. And now we're back to, I have a y on the top, a y on the bottom. So to simplify, I would subtract their exponent. So I would have a y to the top minus bottom. Order matters. 3 minus 5. I can't do big minus small. It's top minus bottom. So be careful. And that will give us a y to the negative 2. Since I have a negative exponent, I'm not done simplifying. I need to do stay or go. So since this is negative, it can't stay. It has to go from the top where it currently is back to the bottom and become a positive 2. All right, so we'd have a 1 over y now to the positive 2. Now that there's all positive exponents, now we're done simplifying. Good final 1 over y squared. All right, number 6. We have a c to the 4th times b squared times an m. Remember, that's an m to the 1st. It might be helpful here to put your individual dots in there to remember that those are individual things we're multiplying together. On the bottom, we have a c to the 1st times a b to the 6th times an m to the 3rd. Now, the first thing I want to look for is just on the top, is there something I can do to simplify, and just on the bottom, right? So if I block this, and I'd say, is there any rule I can do just on the top? And we'd say, in this case, there's nothing that matches, nothing I can put together, no parentheses where I have to share powers, nothing like that. So there's nothing I can do just on the top. If I were to look at just the bottom, same thing. In this particular case, there's nothing we can simplify. So then I start to look at top and bottom and compare. Are there matching bases? And I'd say, yeah, there's a whole bunch, right? There's C's that match it, there's B's that match, and there are M's that match. And for all 3 of these, I can simplify by subtracting their exponent because they're the same on the top and the bottom of a quotient or a division or a fraction. So I'm going to say I now have c to the 4 minus 1 times, do the same thing with your b's, top minus bottom, so 2 minus 6. And same thing with our m's, top minus bottom, 1 minus 3. All right, 4 minus 1 would give us a c to the 3rd. 2 minus 6 would give us a negative 4, so b to the negative 4. And m to the 1 minus 3 would give us m to the negative 2. Now, at first glance, I would say, oh, I'm done. I brought everything up. I did my subtract. But if I have negative exponents like I have here, I'm not done. I have to do stay or go. So c to the positive 3, it is a positive exponent. It stays, right? It's staying put. It stays right where it is. All right, b to the negative 4 right now is on the top, but it has a negative. So it's going to go to the bottom and become b to the positive 4. And then m to the negative 2, again, it has a negative exponent. It needs to go. Right now it's on the top, so it's going to go to the bottom and become a m squared. Good final. Nothing else we can do here. And now we have all positive exponents, so we know we're completely done. Good final simplified version. All right, back to our study guide paper. Let's fill in rule number 6. All right, I'm going to want to fill in my block down here for rule number 6. Hit pause here if you need it. Fill it on in. All right, I hope that helps you attack your work for today. See you guys later.